Hello, in this episode, we're going to be looking at the proposed memorandum for the paper to grade 11 mathematics, grade 11 to mathematics 2025 June examination. So the paper is a 2-hour paper. I'm going to squeeze it at least within 1 hour to see that it is done. Okay, these learners had 9 questions. Answer, and let's dive into it. So question number 1. They're telling us that in the diagram below, A is -5 and 1, B is 1 and 6, C is 7 and -2. These are vertices of a triangle ABC. Then AC intersects the x-axis, okay, at F. And then the angle of elevation of BC is alpha. And then AD is perpendicular to BC and E lies on the x-axis such that these two are perpendicular. AE is perpendicular to the x-axis. Then 1.1. They want us to write down the equation of AE. Okay, so when we are writing down the equation of AE, now we know that the coordinate of the x at E is -5, meaning that the equation is going to be x is equal to -5. Then 1.2, calculate the gradient of BC. So we know that gradient is given as change in y over change in x. So if this is my x1, y1, this is going to be my x2, y2. So I'll say -2 minus 6 over 7 minus 1. Okay. Okay, so when we do the substitution and simplification, that's just going to give us a -8 over 6. Simplify that, which is a -4 over 3. So that becomes the gradient of BC. Then 1.3, they want us to get the equation of AD. Now we know that AD is perpendicular to BC, meaning that the gradient of AD multiplied by the gradient of BC must give us a -1. Okay, so meaning that the gradient of AD, just flip this, multiply by -1, it's going to be a 3 over 4. Then y minus y1 is equal to m into x minus x1 is the general equation of a straight line. So I'm going to use point A. Where there is y, I'll put a 1. Where there is x, I'll put a -5. So y minus 1 is equal to a 3 over 4 into x plus 5, because a negative and negative give me a plus. Open this up. So it's a 3 over 4x plus, that's going to be 15 over 4 plus 1. So it's a 3 over 4x plus, that's going to be a 19 over 4. So that is the equation that the question simply wanted. All right, then 1.4, if L is a point on the same Cartesian plane such that a parallelogram is formed by joining point L with existing points A, B, and C, determine the coordinates of L. So I'll assume we have L somewhere here, because that would be the only logical explanation. That if we have A with L, let's say that is XY, and then this is joined to that, and then we have some sort of a parallelogram. So if that is true, it simply means that AC is a diagonal. So what we need to find is the midpoint, which I'll just leave as M. And then this midpoint should be the same midpoint for even BL. So 1.4, how many marks is that question? It's 6 marks. It's worth it. So let's get the coordinates of M. Or we can say midpoint of AC. So we know that it's x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So that's a -5 plus 7 divided by 2, 1 plus a -2 divided by 2. When I simplify this, that's going to be 1, and then that's going to give me -1/2. So if this is the midpoint of interest, then I can find now the coordinates of L using still the midpoint formula, saying that x plus 1 over 2 should give me a 1, meaning that my x is going to be, this is going to be 2 minus 1, which is 1. Then I'll do the same thing with the y. So y plus 6 divided by 2 must give us negative a half. Cancel the 2's, meaning that y should be negative 7. So L must be 1 and a negative 7. All right, then question 1.5, they want us to find the angle of inclination of AC. Where is AC? This is AC. They want us to find this angle here. Now, for us to get this angle, we need to find the gradient of AC first. So gradient of AC, remember, is change in y over change in x. So our y is going to be negative 2 minus 1 over 7 minus 5, which gives us a negative 3 over 12, which is a negative a quarter. So that angle of inclination, let's say I call it a theta. So theta is going to be the shift tan of negative 1 over 4. Okay, so negative a quarter. So shift tan, negative a quarter. I'm getting negative 14, comma, 0, 4. And then I need to plus the 180 so that I get a positive answer. Okay, so my answer is 165,96. That is what we have, 165,96. Okay, then they want us to get the size of ACD, this angle C here, correct to decimals. Now, for us to get that angle C, we need now to also determine the size of the alpha here. But initially, the question asked us for the gradient of BC. So what I'll do, I'll write it on this other page and say that the gradient of BC was 1.2. 1.2 was negative 4 over 3. So negative 4 over 3. So meaning that our alpha is the shift tan of negative 4 over 3. Okay, when we punch that into the calculator, shift tan of negative 4 over 3 is giving us negative 53,13. Then let's plus the 180. When you plus the 180, we end up with 126,87 degrees. Okay, so this is 126,87. Now, what we see is that if this is 126, even this one will be a 126,87. So you can say F, I don't know which point is this. Okay, this is 126. Then I know that these two will be interior angles, and then this 165 should be exterior. So the answer should be 165,96. We are subtracting 126,87. Okay, so 165.96, we are subtracting 126,87. That is giving me a 39,09 degrees. Okay, so that is how we would have obtained that particular angle. Then 1.75 marks, they want us to get the coordinates of D and then the area of the parallelogram ABLC. ABLC. Okay. Now someone will say, when you look at the previous question 1.4, if L is a point on the same cartesian such that the parallelogram formed by joining the points with existing A, B, and C. Okay, so there's this option here, but then there would be also this other option in this sort of direction. But it's okay, let's move with the option we have, since they never told us where the L is or in which quadrant the L is, okay? So for us to get the coordinates of D, we need to find, do we know the equation? Yes, we know the equation of this. And then we can find the equation of BC. Okay, since we already have the gradient. So I'll use 1 and 6 and find the equation of BC. B is 1 and 6. The gradient, we said, is negative 4 over 3. So we shall say y minus 6 is equal to negative 4 over 3 into x minus 1. So y is a negative 4 over 3x plus a 4 over 3 plus 6. Okay. Then when I simplify this, because I just need to get this equation and solve it with that other one simultaneously so that I get the coordinates of D. So negative 4 over 3x. We know that 4 over 3, okay, plus a 6 must give us a 22 over 3. So this is our equation for BC. Then I'm going to get the equation of BC and then the equation of AD, equate them together, meaning that the 4 over 3x negative plus 22 over 3 should be equivalent to the equation of BC. We got 3 over 4x, okay, 3 over 4x plus, this was a 19 over 4. Okay, so step number 1, I can multiply through by 12, meaning that I'll have a negative 12x. Nope, that's a lie. That's a very big lie here. Okay, so if I multiply by 12 here, I'll have a 4, which means a negative 16x. And then by 4, I'll have 88. By 12, I'll have a 9x. And then what is 19 times 3? 19 times 3 gives me 57, positive. Okay, so I'm going to move the 9 that side. I'll move the 8 that side, meaning that we're going to have a negative 25x. Is that true? What is 16 plus 9? That's a 25. And then 57 minus 88 gives me a negative 31. Meaning that our x is a 31 over 25. Then for me to get the y, I'll just do the substitution, negative 4 over 3 multiplied by 31 over 25 plus a 22 over 3. Okay? So negative 4 over 3, we said we're multiplying it by 31 over 25 plus 22 over 3. So that gives us a 142 over 25. Okay, so those are the y coordinates. Now, having obtained the y coordinates and the x, what we need, we have the distance BC, do we? Because calculate we don't have the distance BC, but we can get the distance BC and then also the distance AD. Okay, so from our distance formula, we say B is 106. Did I follow the right procedures? Good. So it's a 106. And then our C is 7, negative 2. Then our A was a negative 5 and 1. And then our E, we're saying 31 over 25, 142 over 25. Okay, so if that is true, then I need to find the distance BC. So it's going to be 6 minus 2 squared plus 1 minus 7 squared. Punching this into the calculator, it's going to give me that squared plus that, which is just 10 units. Okay. And then our AE, we do the same thing. It's going to be 31 over 25 plus 5 squared. And then 142 over 25 minus 1 squared. Okay, minus minus gives us a positive. So 31 over 25, we are plusing 5 and then squaring it. And then plus, we have 142 over 25. We are subtracting a 1 and then we're squaring that. So the answer we're getting is just 7.8 units. Okay, so then the area, okay, with the area, what I'm seeing is that I can look for the area of this triangle first, which will be the other triangle, which must also be the same as this. because this is a diagonal, okay? So I'm going to say a half times 10 times 7,8 multiplied by 2. So meaning that we have 78 units squared. Okay, so that is how I would have obtained that. And I feel like maybe the marks should have been at least more than 5, yeah? Okay, question 2. We have points P, R, and S are vertices of a triangle with Q being that. Then 2.1. If P, Q, and R are collinear, determine the value W. So collinear simply means they are on the same line and the gradients will have to be the same. So the gradient of PQ should be the same as the gradient of QR, which is also the gradient of PR. Okay, so either way. So let me focus on PQ and QR. So the gradient we said is a change in Y over change in X. So I have my 2W minus 1 minus 3 over W minus 8 minus 2 should give us 3 minus 1 over minus 2 minus 4. Simplify the top one to W minus 4 over W minus 6 should give us a 4 over negative 6. You can cross multiply. 4W minus 24 should give us a negative 12W plus a 24. Move the 12 that side, 16W is equal to 48. Divide by 16, divide by 16, meaning that W is just a 3. So whichever way you use this, you should end up with the same value, 3. Then they want us to get the coordinates of M, which is the midpoint of PQ. So if W is a 3, then this is going to be negative 5. That is 6 minus 1, which is a 5. Okay, they want us to get the midpoint. So it's going to be negative 5 plus a negative 2 divided by 2. And then 5 plus 3 divided by 2. So negative 7 over 2 with a 4. That is what I'm getting for my midpoint. And then they want us to get the value of T if RS is parallel to the x-axis. So one thing we know about the gradients of these two x-axis and that is that the gradient is going to be 0. So I have to do the gradient formula, equate it to 0, and then find that. So it's going to be 2t, t minus 2. So 2t, t minus 2. And then the other one is 4 negative 1. So I'll say t minus 2 minus minus 1 over 2t minus 4 gives me a 0. So the top part will be a t minus 1 is equal to 0. So t becomes just a 1. So that's what was meant to be done for the 2 marks. Question number 3, if cos 23 is this, with the aid of a diagram, express the following in terms of k. So if we have this as our diagram, we don't care about the quadrant. So that is a 23. We know that cos is adjacent over the hypotenuse. So this is 1 minus k squared. This is a 1. So if you do your Pythagoras, okay, it will be 1 minus this entire thing, which is 1 minus k squared. Does that make sense? Meaning that we shall have a k squared, then under square root, we shall have just a k. So the sine of 23 is going to be the opposite of hypotenuse, which is just a k. And then tan of this, we know that 1, 1, 3 is in quadrant 2. Which quadrant 2? Let's say 1, 1, 3. We subtract 180 is going to give us a 67. Okay, I think that's better if we call this a 67. So this is the same as negative tan of 67 because it is tan of 180 minus a 20, minus a 67, which is a negative tan 67. And then tan of 67 is opposite of adjacent to a negative k over 1 minus k squared. Okay, so that is what I'm ending up with. But someone says, is that correct? No, it can't be correct because we're looking at the opposite of 67, which is this. So it's 1 minus k squared over the adjacent, which is a k. All right, then 3.3. The sine of 23 is A, the cos of 67 is B, and then we have that. So let's express this entire thing in terms of base of 2, and then we can be able to get the K. So it's going to be 2 to the 5, and then 2 to the 2B is equal to 2 to the 7. 128 factorize. Okay, then the bases are the same, we add up. So 5A plus 2B should give us a 7. Okay, but we know that A is the sine of 23. So it's a 5, the sine of 23, plus 2, the cos of 67 must give us a 7. Let's substitute. So we know that the sine of 23 is a K, so it's a 5K, plus 2, the cos of 67. Okay, cos is adjacent over hypotenuse, which is also just a K, must give us a 7. Then this is 7K7, meaning that K is a 1. Then 3.4 is the K obtained, valid. Is it valid? Yes, I mean the K is 1. But if we substitute this one back into here, then it wouldn't make sense. Or if you put it back here, because it will be 1 minus 1, which is a 0. So the answer is, I'll say invalid, because the cos of 23 is not a 0. Cos of 23 is not equal to a 0. Question number 4. Okay, in the diagram below, P is that, is a point of the Cartesian. That's R. And then 4.1.1, can we calculate the value of theta? So remember, the question did not say without using a calculator. Ne? So meaning this is a -1, and then this is a 3. So we can use the tan, knowing that the tan of theta is a 3 over -1. Meaning that our theta is the arc tan, the shift tan of 3 of -3. But we could just use the positive part of it. Okay. So the shift tan of 3 gives me a 71, comma 557. Yes. So if you put the negative sign, you're gonna get a -71, comma 57. Okay. But we need the positive aspect of it. All right. So that is that. Then does that make sense? Because if that's a negative, and then you plus the 180. So -71,57. You said we are plusing 180, which will be 108, comma 43. Okay, then 4.1, they want us to get the length of OP. So leave your answer in a sad form. In as much as the question said they never said anything to do with the calculator and stuff, but we can still find just the length using the Pythagoras. So that's gonna be 3 squared plus -1 squared under square root. So that's 9 plus 1, which gives us root of what? Root of 10. Now, without a calculator, they want us to simplify this. So this is gonna be the same as the cos theta. And then the cos of theta here, because I feel like our answer was just supposed to end at 71,57. This addition is unnecessary. Okay, so cos of theta is adjacent over hypotenuse, so it's a -1 over root of 10. Just leave the answer like that. Then the sine of theta minus 180, take out the negative, so it's gonna be negative sine of theta. Okay, because that will be quadrant 2. Then substitute negative, the sine is going to be 3 over root 10, which is a -3 over root 10. And then you leave your answer just like that. Okay, then 4.3, they want us to simplify this. So we know that sine squared of 90 minus, this must give us a cos. So that's going to be, I'll say cos squared of B. And then the tan of 360 minus, we know that tan is in the, okay, this is the fourth quadrant and tan is negative, okay? So I'm gonna change it into a negative sine of p over cos of p. Then we are dividing this by sine of 360 minus, the sign is also negative in the fourth quadrant. So this cos cancels one of the coses, okay? Then we shall only be left with the cos p multiplied by the negative sine of p. Everything is over the sine of p. So this cancels that, and then our final answer should be just the cos of p. All right. So that is what we are getting for 4.3. Then 4.4, determine the general solution. General solution, aim at creating the same ratio, okay? So I can express cos squared as a sine. So 2, 1 minus sine squared using this identity, plus 5 sine minus 4 is equal to 0. Okay, I'll divide through by a negative. So 2 minus 2 sine squared x plus 5 sine x minus 4 is 0. Divide through by negative as you collect the like terms. So 2 sine squared x minus 5 sine x. This and that is going to be a negative 2, which is a plus 2. Then let's factor this out, meaning that we shall have a 2 sine x. This is going to be a sine x. This can be a 1. No, it can be a 2. This can be a 1. Negative, negative. Okay. So if that is true, meaning that sine x here is going to be a half, or sine x is a 2. So we don't have any solutions here. Sine x cannot be more than 2. Then let's focus on the sine x being a half. So with the sine x being a half, we need to get what we call the reference angle. Okay. So the shift sign of a half is going to be 30. This is quadrant 1. Then in quadrant 2, where sine is positive, we shall have a 150 because 118 minus 30. So our x is going to be a 30 degrees plus k times 360. K is the element of integers. In the second quadrant, to be 150 plus k times 360. K is the element of integers. So that is what we had to do with this 4.4 for 6 marks. Question number 5. In the diagram below, O is the center of the circle. We have that chord MS. OV is perpendicular to MS. Can we prove the theorem that tells us that MV is equal to that? So a perpendicular bisector of a chord, as long as the line is coming from the center of this circle. So step number 1, you have to do your constructions. Yeah? Construction and then construction. So you construct so that you have the triangles. Now, the aim of the construction is just for you to prove that these two triangles are congruent. So start by telling us that OM is the same as OS. Reason, you can tell us radi or radius of the same circle. So we have this and that. Then we have OV being the same as OV. This is common to both triangles. And then if OVS will be the same as OVM. Both of them are 90. Reason, these are adjacent supplementary angles. So we have 3 facts as to why the two triangles are congruent. So therefore, OVM is the same as OVS. We said congruent. Reason, we just looked at the side as well as the angle. So for as long as we proved that the triangles are congruent, go down and draw a conclusion that therefore MV will be the same as BS. You get your 5 marks like that. Then 5.2, the diagram below, AB is a chord, okay, of the circle with center O. OMP is perpendicular to that. They're telling us that AB is 14. So if AB is 14, meaning this is 7, that's also 7. MP is a 3, let OM be X, okay? Determine with reasons the radius of the circle. So with your construction, just one side is enough. Start by telling us that the radius is the same as OP, which is X plus 3. Then OP is the same as OA, okay? Meaning that this is also x plus 3. Then from the triangle OAM, okay? And we're gonna use the Pythagoras. So OA squared should give us the AM squared plus the OM squared. So x plus 3 squared should give us the AM, which is 7 squared, the OM, which is just x. We open this up, it's x squared, 6x plus 9. That's a 49 plus x squared. So this x squared cancels the x squared, move the 9 to that side, 6x becomes a 40. And then we're going to divide both sides by 6. So meaning that our x is a 6,67, not degrees, but centimeters. But the question is asking for the radius. So meaning that our radius is going to be a 6,67 plus the 3, which gives us the 9,67 centimeters. So that is how we would have obtained the 6 marks for that question. Question number 6, complete the statement so that it is true. The angle subtended by the arc at the center of the circle is twice the angle subtended by the same arc at the circumference of the circle. Then 6.2, we have this drawing. They're telling us M1 is 53. They want us to give reasons as we find M2. Where's M2? M2 is here. So one thing we know is that M1, okay, plus M2 must give us a 90 because this is a diameter. Reason is angle in a semicircle. And then for us to get the M2, it's going to be a 90 minus a 53, which gives us a 37. Good. Then they want us to get O1. So this is the angle at the center. It must be twice the angle at the circumference. So O1 is 106. Angle at the center is twice angle at the circumference. Then that's 106 done. We move on. They want us to get O2. So O1 and O2 are lying on the same straight line. So it's going to be 180 minus 106. Okay, 106 and 180, we're going to get a 74. Reason, these are adjacent supplementary angles. So you can tell us that these are angles on a straight line. Then question number 7. Question 7, diagram below O is the center of the circle, HECS. HE and SC are produced to meet at I. There's a diameter that's produced, N is 90. And then SE, okay, is the same as EI. So this is the same as that. All right. Then can we prove that nice is a cyclic word? Where is nice? N, I, C, and E. Okay, so I think we're going to use the opposite angles because we already have a 90. If we can prove that C2 is a 90, then we're good to go. So what I'm saying is that SHEC is a cyclic quad, but, okay, C1 is a 90. Let's just use that. Angle in a semicircle, meaning that C2 is also going to be 90 because those are adjacent supplementary angles. Then we're seeing that C1 plus N give us 180 because we're seeing this is a 90. So it is C2. Okay, C2 plus N is 180, or you can tell us that C1 is the same as N, which is 90, okay? Then therefore, we're saying that nice is a cyclic quad. Reason is going to be the converse of the opposite angles. the name without stating a reason, one other cyclic quadrilateral. So you already know this one, the SHEC. Okay, that's another cyclic quad. The other one is this SHNI. That's also another cyclic quadrilateral. All right, then can we prove that HS, this is the same as NI? This. So the only thing we have to do is prove that the angles or the triangles are kind of congruent. If that can be done, then we are good to go. Okay. So what I'll do, I'll start by, since I've proved that this is a cyclic quad, I know that S2 is going to be the same as I1. Those are angles that are opposite, equal sides. So if this is the same as that, okay, then we also know that this H is the same as the N. But why am I using I and I don't need even the I? Okay, I don't need the I because unless if you want to, because we proved that this is a cyclic quad, so you can say angles the same segment, but let's assume somebody did not know that that's a cyclic quad. So start by the 19. So tell us that H is the same as N that is given to us. Now we've proved that this was a 90. Now we've proved that that's okay. Then we know that E1 is the same as E4, vertically opposite, which means that this O2 is going to be the same as the S1. The angles, we can say that the remaining angles of a triangle. And so if that is true, then you can conclude and say that therefore, this triangle HSE, now let's call it a she, is congruent to which triangle? Ni. The reasons we said we're looking at the angles, and if they are congruent, therefore our HS must be the same as NI. Okay, so that is that. Then question number 8, the figure TP, TS are tangents. Okay, R is a point on the circumference. Then Q1 is the same as P1. Okay, this is also X. Okay, can we prove that TQ is parallel to SR? So the only thing we need to do is, if this is a tangent, meaning that our R is going to be X, that is tan what? The tan chord theorem. Now, since that is X, you're going to tell us that R is the same as Q1, which is X. Therefore, TQ is parallel to SR. That's going to be the converse of corresponding angles. Then can we prove that QPTS is a cyclic quad? Okay, so for me to prove that, I need to make sure that I have the same results. Okay, so I'll start by saying that S1 is going to be X also. Reason, angles that are opposite equal sides, or you can still use the tan chord with this. So that is X. And then from that, we can say that S1 is the same as Q1. Okay, so if S1 and Q1, we're looking at this bow tie. Something like that. S1 and Q1 are equal to X. Therefore, QPTS is a cyclic quad. Reason is going to be the converse of angles in the same segment. Angles in the same segment. And then can we prove that TQ bisects SQP? SQP. So the question just wants us to find the size of what? Q2. If we can prove that Q2 is X, then we're good to go. So since we've proved that this is a cyclic quad, meaning that the same angles in the same segment can also be applied here, okay, because there's a bow tie there. So we can say that P1 is the same as Q2. P1 is the same as Q2, which is X, angles in the same segment. Then if that is true, we're saying that Q1 is the same as Q2, which is X. Then you draw the conclusion and tell us that therefore TQ indeed bisects SQP. All right, so that brings us to the end of the paper. They said 9 questions, but I'm seeing just 8. Okay, nevertheless, so that's how the paper was meant to be done. I believe this paper was very, very, very doable and very fair. Okay, so guys, we wish you all the best as you wait for your results. Let's meet. Bye-bye.